Lesson 6, solving nonlinear systems. This will include linear and quadratic, quadratic and quadratic, quadratic and absolute value and linear, absolute value and absolute value. Remember that to solve a system of equations means finding the point or points of intersection. First, let's look at what we're talking about. Recall that a linear function has a degree of 1. Remember that y equals mx plus b, the exponent is understood to be 1 if it's not there. Second, recall that a quadratic is y equals ax squared plus bx plus c. The largest exponent is 2, thus it has a degree of 2. Now, if we want to solve these algebraically first, we need to take a look. We've got y equals x squared minus x minus 6, y equals 2x minus 2. We have a parabola and a line. Where do these intersect? Well, one thing that we do know, when they intersect, the x and the y value will satisfy both the parabola, because the point will lie on the parabola, and the linear equation, because the point will also lie on the line. So let's take a look. And if we want these to be the same, then the y, the blue y, will equal the red y, which will mean that I have the blue expression will equal the red expression. I simply pulled down the blue expression, and then I pull down the red expression and set them equal to each other. Now I'm going to subtract 2x from both sides and add 2 to both sides so I can set my equation equal to 0. Subtracting 2x from both sides gives me minus 3x. Adding 2 to both sides gives me minus 4. Now I can factor. Factors of negative 4 that will add up to negative 3, x minus 4, x plus 1. I set each factor equal to 0, 0 product rule, and I find out that the x's that will work are 4 and negative 1. Now I need the y values. I should get the exact same thing regardless of whether I use the linear equation or the quadratic equation, because the points intersect at these spots. Now, I personally prefer using the linear. I don't have to worry about squaring anything, fewer operations, fewer opportunities for me to make goofy arithmetic mistakes. You may use either. Both, assuming you do the correct arithmetic, will give you the same answers. Now, first, I substituted in to the linears so that I got the 4, 6, and negative 1, negative 4. But just in case you want to check and use the quadratic, that's fine. I did it on the quadratics as well, and notice I got 6 and I got negative 4 again. The solution to this particular linear and quadratic system are the points 4, 6, negative 1, negative 4. When we say the solution to the system, okay, solution to an individual equation is the x-intercept. The solution to a system is the point or points where they intersect. In this case, we have negative 1, negative 4, and 4, 6. If we graph the parabola and we graph the line, these are the 2 points in which they intersect. Going on, we can take a look at another one. We have y equals x squared minus 2x plus 1, x minus 3. We can use the same concept. We can set the x expression equal to the x expression, and then right here we've got the x squared minus 2x plus 1, and then we take the x minus 3. Oops, okay, I thought I got it. The x minus 3 on the other side, subtract x from both sides, add 3 to both sides. Whoa, it won't factor. Now what? How we can complete the square? Well, when we complete the square, or we can use the quadratic formula. Let's see if we can do this. We're going to come over here and remember what the quadratic formula is. I'm going to pause this for just a second. Okay. To use the quadratic formula, remember that x is equal to plus or minus the square root, oops, sorry, I'm ahead of myself. My pen isn't wanting to work, so I'm having to use my finger, which is a little bit big on this. So it's equal to negative b, so this is going to be negative 3, plus or minus the square root of b squared, negative 3 quantity squared is 9, minus 4 times a, which is 1, times c, which is 4, which is going to be 16, all over 2 times a. Going through all this, negative 3 is a positive 3, plus or minus the square root of negative 7 all over 2. Uh-oh, we can't do this. Not yet. When you look at this, you're going to notice that we have a negative under the radical. Remember that the discriminant tells us that this means there are no real solutions. No real solutions. So again, look here. We've got 3 plus or minus I root 7, okay, over 2. Don't want to get too much into that because when we get to Unit 5, we are going to get into imaginary solutions. Just suffice it to say that when you've got a negative under the radical, there's no real solutions. Didn't work. Now sometimes instead of being a negative, you're going to wind up with an irrational. An irrational would be a real solution. It just isn't an exact solution. You can't give it an exact decimal. Now here's another dilemma. What to do, okay, when you don't have any like terms? Well, if you don't have any like terms, solve for either x or y. I've got 4y equals 3x. Y is equal to 3/4 x. I could just as easily have gone the other way. Now I'm going to square both terms. Y is y squared. Over here, 3/4 x becomes 9/16 x squared. I simply squared both sides. Now I can substitute and solve. I know y squared is the same thing as 9/16 x squared. So I'm going to take this 9/16 x squared and I'm going to put it right up here into this y squared. Now I have one equation in one variable, and I can solve that. I can go through and I can change, oops, let me make sure I get this so that you all can see the answers. I can go through, and this is 16 over 16. Oh, I wish my pen would work again. So I have 16 x squared over 16, that's the same thing as 1, plus 9 x squared over 16 is equal to 25. Do I want to stay with 25 or do I want to do the 25 over 16? Well, 25 times 16 is 400. So I'm going to have 400 over 16. Over here, 16 plus 9 is 25. So I have 25 x squared over 16 is equal to 400 over 16. Now, what do you think you would do next? Think about it. Think about it. Okay. If I multiply both sides through by 16, I'm just going to have 25 x squared is equal to 400. How did I do that? Well, let's take a look. If I multiply this side by 16 and this side by 16, notice that the 16s are going to cancel, and that's what's going to leave me with the 25x squared is equal to 400. Now, What do I have to do? Well, I've got to divide both sides by 25. X squared is equal to 400 over 25. I am now introducing the radical, so I'm taking the square root. So x is going to be equal to plus or minus, what's the square root of 400? Anybody? Oh, hopefully you said 20. Square root of 25 is 5. And when you simplify it, you're going to get plus or minus 4. Again, it's going to be equal plus or minus 4. Now remember, that's only the x value. You have to take 4 and plug it back into either one of these equations. I personally would plug it back into this one. And you wind up with 4, 3, and negative 4, negative 3. Those are the 2 points that this circle, hopefully you recognize this guy here, he's a circle, will intersect with this line in these 2 locations. Next up, what do we do when we have a circle and another line? Well, this is the same idea as before, just this time we're going to square an expression. So I get y by itself with a linear, and then I square it. Don't forget, you have to FOIL. Okay, if you don't FOIL, it's not going to be right. So when I square this expression, it becomes 36 minus 12x plus x squared. I substitute it in, combine my like terms, divide through the entire equation by 2. I factor, and look, I get 2 different values of x. I can now plug x in. 1 plus y is equal to 6. That'll give me 5 as the y value. I can plug 5 in for x and get 1 for y. You can also plug them into the circle. I, again, would prefer to plug it into the line. You have a circle and a line, and they intersect in 2 locations. Now, solving systems graphically, actually even easier. Step 1, graph one of the equations on a coordinate plane. Step 2, graph the other equation on the same coordinate plane, not on a different one. Doesn't help. Step 3, locate and identify all the points of intersection, if there are any. Remember, sometimes there aren't any. Let's look at a couple. Here, we solve graphically. Y equals x squared minus 4x minus 2. First thing I have to do is find the vertex using the negative b over 2a. Once I get that x is 2, I plug the 2 in. And I plug the 2 in for the y, or in for the x, and solve for the y, so I get 2, negative 6. There's my point. I then look at the parabola. A is equal to 1. There's no stretch or compress. It opens up. So I go right 1. So I go right 1, up 1, right 2, up 4. What I do on the right, I do on the left, and then I draw my parabola. My line's a little bit easier. I have the y-intercept is negative 2. The slope is 1. Rise 1, run 1. Rise 1, run 1. Using a straight edge, I draw my line, and then I look. I look and I identify 0, negative 2, 5, 3. These are the points of intersection. Linear quadratic systems can be solved algebraically using substitution or graphically. The solution or solutions is or are the point or points of intersection. A solution will satisfy both equations. Solutions can be imaginary or complex, and these right here, okay, we're going to get to those in Unit 5. Unit 5 is when we wind up doing imaginary and complex solutions. At this point, the only thing that you're going to say is there are no real solutions, just like we've said when you've been doing the discriminant. If the discriminant, the value underneath the radical, is negative, then there are no real solutions. They are imaginary or complex. Now, there may be more than one solution. If you've got a quadratic and a line. It can intersect in two different points. Two quadratics, those can intersect in multiple points. A quadratic and an absolute value could intersect in multiple points. If you're given the graph, you're just finding the point or points of intersection. That's it. Good luck.